So hello everyone. In this project, I will be running a simulation for different motor frequencies through a wind tunnel using ANSYS Fluent. Okay. So you want to start by going to your workbench where these tabs should pop up, and you're going to choose your analysis system, which for this project we chose Fluid Flow Fluent, which you will mostly choose for your simulations. So once you choose Fluid Flow Fluent, you're going to then create your geometry. Okay. So, geometry. Okay. All right. So once you have your geometry popped up, you're going to create your geometry, which for this project, we created the wind tunnel component of the contraction chamber, the test section, and the diffuser. Okay, so you can draw your lines pretty much, then you can fix it, your constraints, your dimensions. Okay, so once you have your wind tunnel, obviously here are the dimensions, you can adjust them to to whatever you want to adjust them to. For this project, these were the dimensions that we used for it, and we got the wind tunnel. Okay, so once you have your geometry, you want to mesh it. So you go to the meshing tab. Okay, and this is where you select your boundaries. Okay, so here is the velocity inlet, here's the pressure outlet, and this is the tunnel wall. And we used for the meshing process the all triangles method. Okay, that's what we use. So once you have your figure meshed up, you want to go to the setup, and this is where you're going to get your results. Okay, so you see you have your velocity inlet and your pressure outlet. Okay. Now for this project, we were to calculate different frequencies from 10 hertz, 30 hertz, and 50 hertz. But for the sake of this video, I will only be calculating it the 10 hertz, which I believe is 2.2 meters per second, roughly around that. Okay. So again, you can choose between inviscid, laminar, and turbulent. I'm going to use turbulent for this video. These other ones are also pretty good for turbulent, but I'm not too familiar with those. So I'll use Spalart for turbulent. Okay. Okay. You want to have your energy equation on. Okay. You can see your fluid, and here we're going to obviously working with air for the wind tunnel. So you see, you can edit it, and you can choose other fluids. If you want to do simulations with other fluids, you can also do that here. Let me see where we can change the, okay, here is the velocity inlet. Here's where you can change your inlet. You see it, velocity is already at 2.2, but if you want to change it to a higher frequency, you can change the velocity here. So you click apply. Okay. And you want to compute it from the velocity inlet. Let me see where I can find that. All right. Okay, again, stationary wall. We're not changing anything here. If you want to add a moving wall, here's where you can add it to here. Okay. No. Okay. So anyways, after this, you want to initialize your problem. Here's where you would do that. Use the hybrid one with 10 iterations. Okay, once that's done, you want to run your calculations. And now I put 300 iterations, but this problem actually converges at around 60 iterations. So you can adjust your iterations around that. So okay, so once we start our calculations, we want to wait for it to converge, and now it's just pretty much a waiting process. Actually, I'm only going to run 10 iterations because I don't want to make this video too long. Okay, so okay, we click stop. Again, you can adjust your iterations here. Once you have that, we wanted to find for this project the pressure contours, the velocity contour, the static pressure, total pressure, and dynamic pressure in the wind tunnel. Okay. So in order to find the contours, you want to go to your results tab, click on graphics, and here are your contours. Okay. So we first want to find the velocity. Click velocity through, I believe it was through everything here. Click compute, display. Here is your velocity contour. Then if we want to find static pressure, we go to pressure, compute, display. Likewise for the dynamic pressure and for the total pressure, just click on compute and display. We also wanted to plot the variation of velocity, static pressure, total pressure, and dynamic pressure along the wind tunnel center line. Okay, so you go to your plots, XY plot. Okay, and you first have to create your center line, which is just from -2 to 2. And here, the way you create your center line, I believe, okay, here it is, sorry. So yeah, you just create your line from -2 to 2. You create, it's already created in mine, but you could just create and name it center line or whatever you want to name it to. Okay, so again, if you want to find those plots, we just velocity, we're going to first find the, okay, now here's your velocity plot along the center line. And again, you could do that for your pressure, static pressure, dynamic pressure. You can do that for your total pressure as well. Okay. The third step was to plot the vertical velocity, static pressure, dynamic pressure, and total pressure distribution at the center of the test section. So now it's just a vertical line that we're going to be calculating it from. So again, you just click create line, and now it's just going to be from your Y, -2 to 2. Just click create, and your vertical line should be popped up. Just you also have to name it, okay, for that one. Now, same thing, but except we're gonna use it from the vertical line. Velocity. Actually, it's not created on mine, so let me just go ahead and name it as well. Let me click create. All right. Name it vertical. Okay. Okay, see, now it is. Okay, so again, it's going to be through your vertical. This is going to be your velocity plot. Let me see. You can see it here. Again, for pressure, static pressure, total pressure, and your dynamic pressure. Okay, so that's how you do it through the vertical line. Okay, so now we were also required to plot the pressure change in the contracture chamber versus the dynamic pressure. Okay, so the way that we did that is with the velocities, we were able to calculate the dynamic pressure, and from there we were able to calculate or plot pretty much the pressure change across the contracture chamber, the pressure entering, the pressuring out minus the pressure in, and we were able to plot that against the dynamic pressure. And the value, we have to find the slope, but the slope is going to be approximately 1. That's pretty much a close value from your dynamic pressure and your change of pressure. Okay, so I believe that was it, what we did with this for this project. Let me see. Yep. Again, I want to thank everyone for watching this video, and I'll see you on the next one.